Everyone. I hope everyone is doing well during this and hanging in there. I miss you guys. The last section that we have to cover in chapter 3, and then we can basically quiz out of it, is if we know that angles are either congruent or supplementary, it's going to give us enough information to prove that lines are parallel. So let's look at the 3-3 notes, and it's called proving parallel. And what's actually going to happen, it's just the converse of what we already know. So we know the corresponding angles postulate. We already know that. And the postulate says that if lines are parallel, cut by a transversal, then angles are congruent. Well, now we have to know what the postulate is. And it's if two lines are cut by a transversal and the corresponding angles are congruent, then the lines are parallel. You're going to say, if corresponding angles are congruent, then lines are parallel. So right here, I asked you in this question, would I have enough to say that M and N are parallel? Well, this talks about same side exterior angles. It does not say that they are corresponding. This would be corresponding, and I don't tell you that that is corresponding to that. So as of in this example, we do not have enough to say that they're parallel. Later, we probably would. We're going to have our alternate interior angles converse and our alternate exterior angles converse. And I'm assuming you could guess what this is. It's if two lines are cut by a transversal, if alternate interior angles are congruent, then lines are parallel. If alternate exterior angles are congruent, then the lines are parallel. Okay, let's see. Our last converse, our 3.6, says same side or consecutive, depending on the textbook, interior angles converse. Now remember, the same side interior angles theorem says that if the angles are supplementary, then lines are parallel. So now this is going to say if the angles are supplementary, then the lines are parallel. Sorry, the theorem says if the lines are parallel, then they are supplementary. So we just have to remember. So take a second. Would you have enough to tell me that the lines AB are parallel in each one? So for example, this red dot, this red here, and this red here tells me they're congruent. Well, since they're alternate interior, if alternate interior angles are congruent, then lines are parallel. So here, yes, these are corresponding. That would be the corresponding angles converse. And then this one tells me that angle 1 and angle 2 add up to 180. But the problem here is angle 1 and angle 2 are alternate interior, and the only way for them to be parallel would be if alternate interior angles are congruent. So this does not prove it. Here is your summary. This side is the theorems here, and this is everything. If you're given parallel lines, then alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding angles are congruent. Same side is supplementary. These are your converses, that if you're trying to prove lines are parallel, then alternate interior angles must be congruent, alternate exterior corresponding, and same side must be supplementary. So now let's go down and look. And here's something we want to talk about. So go ahead. I want to give you a second to get here. Okay. One thing you're going to notice, we are not going to really dive deep into proofs given that I'm not there and they're very hard. But we're just going to go over a few basic and then get out of chapter 3 because chapter 4 is pretty easy to start. So if we have to start online, it's going to be pretty easy. But let's look here. Angle 4 congruent to angle 5 obviously is going to be our given. One thing I want to talk about. So now, in the past days, we've proven everything alternate interior, alternate exterior, corresponding, and same side. So we can use any of that. What I want you to look at is this. If you are proving that lines are parallel, so my last thing here is that they are parallel, it has to be by a converse. If it does not, if you're trying to prove that angles are congruent, then that's when you're going to use the theorems. But right now, it's going to be a converse. So let's look at this. I tell you 4 is congruent to 5. I know simply that angle 1 is congruent to 4. We should know why that is. And if I can get that angle 1 and angle 5 are congruent, they're corresponding, that would tell me that the lines are parallel. So that's the way we're going to go. So we're going to say angle 1 congruent to angle 4. I'm going to let you skip right to the ACT. I'm not going to make you tell me their vertical angles, then tell me they're congruent by the ACT. We talked about this. We did so well in chapter 2. We're going to go right to the ACT. And then 4 can cancel. So angle 1 congruent to angle 5 simply by substitution. So now that you tell me angle 1 and angle 5 are congruent, which they are, and now that they are corresponding, you can tell me the lines must be parallel by corresponding angles converse. You just have to remember that if you're proving lines are parallel, then it's the converse. All right, let's look at this one, which again, if we look here, we are trying to prove that P is parallel to Q. Right here, I know that R and S are parallel, which means if R and S are parallel, it means this is a transversal, which there's only the angle 3 on there. Here's a transversal. So now I know angle 1 and 2 are going to have a relationship given that R and S are parallel, but we're trying to prove P and Q are parallel. So if I can get 3 and 2 to have a relationship, then I can say the lines must be parallel. So let's look what in angle 1, I should say the measure, a little old. I'm going to say angle 1, measure of angle 1 equals measure. It could be congruent. Right, let's do angle 1 congruent to angle 3 by definition of congruence. Just okay. So now I know 1 and 3 are congruent. What you have to be careful here is I told you that these lines are parallel, this one and this one. So that's what's actually parallel, which, like I said, makes P a transversal and Q a transversal. So now if these are parallel, I can say angle 1 congruent to angle 2 because of corresponding angles postulate. All right, it's not the converse. It says these lines are parallel, therefore they're congruent. So now I have 1 and 3, 1 and 2. I can cross out 1 and say angle 2 congruent to angle 3 by substitution. And now if I look, angle 2 and 3 are what type? So if I know that 2 and 3 are congruent, then I can say P is parallel to Q because they're what type of angles? Alternate interior angles converse. Good. All right, that's where we're going to stop. I'm going to give a couple proofs as practice, and then I'm going to give a review sheet to look through with an answer key, and then when I get final direction, if I'm allowed to, I'll send out the quiz online, probably in OneNote. You can do it. I'll grade it through OneNote and we'll wrap up chapter 3. I'm just waiting for a little more further direction on if grading is allowed or not via online. All right. Hope everybody's enjoying. Have a good day.